Good evening. Uh, so tonight I would like to, it's going to be a theoretical video, and I want to show you a few things of what I have now done and completed. And this will get us to the last stage of fixing the rough idle issue on my car, at least. This issue will vary on different vehicles depending on mileage and age and overall condition. Just to recap, mine is an 89 model year, 560 SEL, and 332,000 miles on it. And as you may remember, I did a compression check. We replaced almost the entire fuel distribution has been renewed. Fuel distributor, fuel injectors, the pump system in the back with pumps, filters, fuel strainers, etc., etc. And we have a new EHA valve on there. We got a new idle control valve on the system. We fixed the entire vacuum leaks we had, whether it was the injector seals or the intake manifold, donuts, and everything what was associated with it. We fixed the leaking or malfunctioning transmission modulator. And so now I got to the point where the last part was now to get the ignition system rebuilt, and we did that. I did that too. I got the rotor distributor cap, which is working okay, and spark plug wires, new spark plugs. We fixed the idle speed control module. We fixed the fuel pump relay. We changed the computer out to the correct computer ECU in there. The RPM sensor was replaced, the oxygen sensor was replaced, and the temperature sensors were replaced. The throttle position switch was replaced and correctly adjusted. So all of this stuff has been completed, and like I said, I did a compression check, and I got 10 bars, plus minus, say like a half a bar. That's about 150 psi. The lowest one I had was 142. The highest one we had was 155 on the cylinders. So all that checked out good, but I still have a rough idle. And the first thing is, as you can see this here, is to check is the ignition module itself, which is this here. And you can see I got a new one already, and this one here. And this one, actually, this surprised me really. This was built or manufactured on January 9th, 2003, so this is quite old. It came not directly from Stuttgart, but Gemmersheim, where their main storage unit is. And you can see the box has virtually no shelfware. Since it's set there, and it is sealed, I didn't break the seal. And this is how this is basically packaged. This is now my old one, because I got this one, the new one, which came in already in there. And you can see there's no dust or anything in there. This is now the replacement unit I had bought. This is my heatsink compound I put on there. And what happened is, this was a unit I got off eBay, because I had the one in my car from a 420 SEL for a 116 engine, which has different timing advances. So I got this one here for $200. And what happened over the last, I would say, 8 weeks or so, is that the vacuum port was giving me problems. And the ignition, just as a short recap, the ignition module regulates the advance. That's the only thing what regulates or changes the advance. And the system itself is basically the brain. It has a microcontroller built in with several different settings stored for different situations, and that unit will then adjust the timing correctly. That's why your rotor, the distributor rotor, is fairly wide, so that gives that thing an ample time to set the advance any way it likes. This is the RPM sensor, which comes from the flywheel. They call it the rear crankshaft position sensor, but it is really an RPM sensor. There's 4 notches on the flywheel. This unit does not know where your top dead center is, or 0 degree mark, and it does not care, because your rotor does that. All it does is it divides the timing between the four marks or the four dimples in there by 2 cylinders, so it will just fire then accordingly. So you have, for every revolution on the flywheel, this input signal here is 4 pulses. This unit here has a Schmidt trigger built in as a filter, and it converts these needle impulses, basically, which come out of the proximity sensor, what that basically is, into a square wave signal, which varies in frequency but has a fixed pulse duty cycle of 50%, which is then distributed over to all the other components within the car, the ECU, the idle speed control unit, I think the speedometer, no, not to the speedometer, but to those 2 units, which are primarily concerned about the RPMs. And then on the lower part here, we have input 4, 2, 1, and 3. 4 is not connected. There's a wire in here, but it doesn't go anywhere. Then 1, I believe, is the 750 ohm reference resistor, which measures 753 ohms and is in spec on my car. Then we have the temperature sensor, B12-2. One of those signals goes here, so it knows how cold or how hot the engine is. And then number 3 is the throttle position switch on the bottom of your throttle, and that will shorten to ground when it is at full throttle. When you step all the way down and the throttle is fully open, this pin will be pulled down to 0 or to ground, and that gives us the signal. On the output side here, we can read this actually. Let me see. This is really nice. TD. That is your timing signal. That is the actual RPM coming out. These are the circuits 15, 16, and 31 going to the ignition coil and coming from the ignition switch and the plus supply. Or the ground, actually. I think one of them is the ground and the plus goes to the coil. So this is basically all what this unit lives off. And the way you test this, the only way you can test it is you have to get your engine cranked over and check all of your marks for 0 degrees, top dead center. That means you're rotating the crankshaft, you go to the 0 degree mark on your pulley, on the what do you call it, not the idler pulley, the balancer. On your balancer, you go to 0 degrees, you open your rotor cap or your distributor cap, and you make sure that the rotor is on cylinder 1, and there's a mark on the housing itself that needs to align with the mark on the rotor. And if it doesn't, there's a screw, I think it's a 13 millimeter, you can loosen up and you can rotate this, and you get then the rotor exactly lined up with that mark and the indent on the housing for the distributor. That way it is set, then you tighten this down, and then you check your 2 camshafts, and they should align with the 2 marks on top. That's all there is to it. That is how you set the timing on it. No matter if you reassemble the engine before you put the chain in, it's not a big deal. You always can get the thing back into shape because of these 4 marks they got. This is virtually a foolproof system. Once you got this, you need another thing is we have the vacuum going here, and this vacuum port goes directly to your intake manifold. It has a rubber piece usually on here, and then you have the white hose going over to it. It comes straight out it. And in order to check this, I got one of these gauges here from Ken Bergsma. He sells those at Mercedes stores, and it is just a rubber hose, and I put a T on it so I can connect this here and then go to the engine intake. And at idle speed, so 650 to 700 RPM, you should be reading between 15 to 20 inch mercury. Let me see if we can get a nicer picture of this here. Then you can actually see this. Whoops, now we got the light in it. There you go. Minus 15 to minus 20. Recommended is minus 18, which is right there, minus 19, somewhere around there. And then you take the timing light, the old-fashioned timing light, and you point this straight down in the opening between the distributor and the water pump, and then you will see that little pointer they got above the balancer, and you will see the marks. And what needs to be happening is it should be between 12 to 14 degrees with vacuum at that minus 18 inch mercury. And if you disconnect the vacuum and you close that vacuum line off, it should be around 5 to 7, so below 10. Because they have 10 degrees, 20 degrees, 30 degree marks, or 40 degree marks. What happened here, and then you know this unit is working right. This is all what it does. And what happened on this one is here, because there is a membrane inside that thing, which that port, and that attaches to a sensor, which measures the inch mercury. And the calibration point is minus 18 at 650 RPM. And that will then advance this to that 12 to 14 degrees. It's not 100% exact science, but that's basically where it is at. Inside this thing, there's a little tiny bleed hole in there. And what happens is when the thing ages, is two things can happen. Is the bleed hole can get plugged up, and that will increase the vacuum in here. So, and that will change your timing. That means you're gonna be, say, like at minus 20, at 20 degrees, 30 degrees, or what have you, and you're still having only minus 18 inch mercury of vacuum on there, but it will actually, the system will think it is at a much different higher vacuum actually, because it is no longer allowing the bypass, or the bleed hole doesn't allow for proper venting in there to balance this. Or the membrane breaks altogether, then you plug the vacuum in and it makes no difference. You're basically stuck then. You should be stuck at the idle RPM at 7 to 10, no matter how far you go up with the RPM in the advance. And what happened on this unit here is that the bleed hole in here, there must have been some dirt behind it accumulated over 30 years. This unit here, I cannot tell you when that was manufactured, but that is quite a bit older too. Let me see if we had a manufacturing date on this. I don't think that there was, but I would think that this is out of the 90s, early 90s. That was a replacement module. And so it has quite a few years on it, and it came out of a 560 SEC, same engine basically, but with a newer, it's kind of newer style than what the other ones, the previous ones had, which were made from 85 to 90. So this is the slightly newer version of it, but it makes no difference. And what would happen here is that bleed hole would plug off suddenly, and then my advance would jump literally from 12 to 14 degrees all the way over to 40. I mean, it was just a complete jump, and it would drop back off. It would jump and it would drop back off. And that will rev up your engine up and down, up and down. So you will get a rough idle from this. That's why I replaced this unit here. And again, you need two tools in order to verify this. You need to verify the vacuum, that you get the correct vacuum on there. 18 inch mercury is what you want. 15 to 20 is permissible between 650 to 700 RPM. And you need the old-fashioned timing light to see the marks on the balancer with that little pointer. So now I got the new ignition module in there. This no longer jumps to the 40 degree mark, but I get a slight advance. And what I see is on my dial is that at idle at 650, 700, I'm at minus 18. And then it goes to minus 22. It goes back to minus 18, minus 22, minus 18. And then every time that changes, it changes the timing on there, which I can see with the timing light. So it goes from 14 degrees, 12, 14 degrees to about 18 degrees, not quite 20. So it is going with the change in vacuum. And that now I know that I fixed all of the vacuum, so I re-verified everything, disconnected the brake booster, closed that off, no difference. Closed off the vacuum line down to the transmission modulator, no difference. Closed off the line to the air conditioning system for the climate control, and no difference. I closed off the line to the EGR valve, no difference. I closed off the line to the system which vacuums the tank, the purging system, the fuel vapor purging system, no difference. So that brings me now down to the last piece, that the idle problem I got is internal to the engine. And like I said, the engine has 332,000 miles. You can't do this. You have to fix basically every part little by little by little. One thing is bad, then you have to go on and fix this. Then you go on and you fix the next thing, and you fix this, and you fix that, and you fix this. And then by the time it is all fixed, then you're done and you're fine. Now, if you may remember this, in my videos in the big repair, I showed you that we had a already rebuilt fuel distributor in my car, which was rebuilt by Bosch. I would think that may have been around 2007, 2010, when the car had 250,000 miles. Those fuel distributors, with their membrane in there and the seals they got and everything else, they're probably good for about 10 to 15 years. And then they have to be replaced. There's just no way, rebuilt or replaced, either one of the two. There's just no way around it. So I replaced it, and the way I discovered this, that fuel distributor was on its last leg, was that my cylinder 8 was leaking. That means that was getting fuel into the injector and into the engine, while all other 7 injectors were basically off. And that depends on the plate. You know, when you're on with the plate, when there was no fuel running, there was fuel coming out of cylinder 8. So cylinder 8 got by far more fuel into the cylinder 8 than the other 7. And what I suspect that that created a problem with the valves or the piston, or both. This is what I'm suspecting right now. And that would correlate to the issue is that the valves are no longer fully closing. And the reason why I'm saying this is the issue with the rough idle increases with engine temperature. So when everything starts to get hot and expand, and cylinder 8 gets hotter than most because it is in the left rear corner, and or the last one, and that is the exit point for the hot water to go into your heat system for the cabin. And the, what did they call that thing there, the heat exchanger, the heat coil system. And then it comes out and goes to cylinder number 4, where it re-enters it, usually cooler. And it also goes into the cleaning system, the wiper, the window wiper system. So that reservoir, there's a hose going over there, which constantly heats up that windshield wiper cleaning fluid to get that nice and hot. So that's by cylinder 8. And this is also the reason it gets hotter. And that is also the reason why that rail, that oil distribution rail on top of the cam, comes out or pops out at the rear on cylinder 8 first, and then it goes up to the front. It's just a sequence on how the cooling fluid goes through the car and the you know, so everything that is basically your hottest point back there. And in order to test this, I had to go to verify this. We had to get us one of these things here, and that is a Bosch. Let me show you this. It's quite a big piece. This is a Bosch Druckverlust tester. That means a pressure loss tester, and it hooks up here on the bottom side to your compressed air. I need to get a female fitting for this, which is coming tomorrow from Amazon. And then on this side here, it just simply screws into your spark plug port. And then the way this works is you can disconnect it. It has a quick disconnect here. They have a insert here. You can see this has a fairly large size hole, and they have what they call a calibration tool, which is basically this thing here with the smaller diameter. And because you can vary this on operate this on various shop pressures from 65 to 200 psi, you plug in the calibrator with that small hole, and then you turn on this here, on this wheel here, until the needle shows calibration mark, which is about 23, 22, 24, 20, 23%. And then you have it set up, and you need, when you operate this, you basically have to make sure that it doesn't, that your shop pressure is stable, so you don't have someone running the largest tool in the shop with 10 tools at the same time. So you want to have that, or you want to do this while the compressor is fully charged up with the tank. It won't take very much air going through this, but it should be stable so you don't lose your calibration. And then you hook this up. You have to open, of course, the camshaft covers, and you rotate your engine over, and then you go through from cylinder to cylinder, and you got to be a top dead center for each one of them. That means that the cams are up, the valves are closed, and then you see where this is at with the compression check. And now comes the analysis of what you're seeing. I'm going to show this when I'm going to do this on the car. The goal is that you have zero loss, but there will be some loss. And if you have a race car, you probably don't want to be higher than 2 or 4% losses, if they even go that far. The critical mark is 20%. That's basically when it gets critical. Once you go with a loss of higher than 20%, then you can, two things, that's getting to the point where you're looking at problematic valves, most likely. And in order to verify that, is if you have that much loss in one cylinder, is you unscrew this here basically. Where did I put it now? It's over here. You take this back out of your cylinder and you squirt some oil in there, and you reattach this and run it again to see, is it the piston rings or is it really the valves? Usually if they're between 10 to 20%, that is the adjustable range, and that's where this comes into. So again, 10 to 20% or anything zero more than 5% to 20%, this is where this comes into the game. What they're calling the hydraulic valve clearance compensating elements, or shims. And that is something which is going to come then next. So once I get all 8 cylinders checked out, oh yeah, the other thing is what you can do is, say like you're at 10% or 15%. The first thing what we usually do in that case is to go to the back of the muffler and see if you're going to hear a sizzling noise, because that air is going to go most likely through the exhaust valve out into the exhaust, and you can hear this make like, and you can clearly hear this because the exhaust itself amplifies that little bit of air coming out of there. So at that point, you know for sure that it is your exhaust valve. If there's nothing coming out of the muffler, then you have to lean over and listen into the plate for your fuel distribution system, the air intake, the airflow plate, and then you will be able to hear it coming out of the air intake system. Then you know it's the air intake valve on that cylinder. So first, when there's a loss, disconnect it, put oil in it, make sure it's not the rings. Then you check it's the exhaust valve or the intake valve. And so then you write it down, you go through the whole engine. That whole process maybe takes an hour, 2 hours, depends on how fast you work. But you have then a complete picture of the engine, or the cylinder heads, valves, and pistons at the same time in terms of torque, of pressure loss. It's not compression test, it's pressure loss. And that it means leaking cylinders. And this is made by Bosch. Let me just show you the number for those who may want to have this. Bosch still makes this part. This comes, I mean, this is heavy. This is the real thing. This is how they make, or used to make, test equipment. I would think that thing probably weighs at least 5 pounds, if not more. This is real Bosch quality. This is what I'm used to when I hear Bosch. This is what I envision with Bosch, is this here. You hit someone in the head, you know that you hit them. Someone sleeps around in the shop or whatever, you give them a whack with this thing, it won't get damaged. And you can see this is it. They're selling it 2,000 euro with this hose, with one fitting, and with the with that insert for the top, what they call the calibration tool. 2,000 euro. I was lucky. I got this from a guy in Russia, of all places, 300 miles northeast of Moscow, and he sent it over to me. He said, it's going to work, no problem, no problem. And it came by Russian mail, and it got here. It took 4 weeks, and it came perfectly. He had it packed up, double packed, triple packed, six packed. And I tested it already, and it working beautifully. 2,000 euros. I paid 350 for it. The calibration tool with shipping from Germany is 100 extra, so 450 versus 2,000. But this is the best analytical tool even today on those engines, what we call suction engines or Saugermotoren. That's what they were called. All of those, we got that K-Jetronic or Jetronic intake fuel system in there with that airflow moving through, and the mechanical fuel distributor basically pushing this in and regulating the fuel flow in this. This is what you need. This is the core. So now once I know this here, then I can make a decision. If it is, say, like past 30, then you can already say that entire cylinder head, if it is only the head, because of the oil in there, has to come off. Because once you got 30% loss, you can no longer shim this out. And the way the shimming process works is that requires two tools. First of all, these are the thicknesses which are available, and I verified this with Mercedes-Benz. They still got all of them, some of them more, some of them less, some of them in Germany, some of them here in the States. And these are the two tools. The one is this here, the test gauge for hydraulic compensation elements. Baum Tools sells them. I got them from Tools, I would say Tools Express or something like this. $100, and the valve spring compressor or the spring compressor is 120, 220 plus $14 in shipping for these two. I ordered them. You can't do it with neither one of the two. You have to have both tools. You really need all three. You need this thing and you need these two tools to do this correctly. And this is basically how this works. Is that tool goes on the side of the what do they call that thing here? They have that funny name for this. Let me just see. They call that hydraulic valve. That's right. That sits on top of the hydraulic valve. The hydraulic valve is this here, that white part. And it has that rocker arm on it, which then compresses down on the spring-loaded valve. And number 4 is the actual shim. So you set this thing on here. This is something which is really interesting. It doesn't give you a number. So they did this really foolproof. And so you can see this. This has only a notch in here. This is the tool. And when it goes down, that means you have to increase the shim thickness. And if it goes up, you have to decrease the shim thickness. And boy, this is hard to see. But here they're showing you on how the camshaft has to sit basically up, and you can see the top of the tool here. And you can see the cam is exactly top up, and you have to make sure that the piston is at the highest position when you do this test. Also here, so that is clear. Let me just see. Yeah, here you can see this, I think. Yeah. See, we can zoom in like this here. You can see the tool. It is slid over the actual hydraulic valve, and it sits there and it measures that ball on top there. And then we can take a look at this and see. And then you can see this is 1.2 millimeters that gap they have. And if that doesn't need any adjustment, it should be right in the middle. so 0.6 millimeters. And you can see this if it is flush, when the top part is flush with the lower one, then you have to install a thinner thrust piece. And if the lower part is flush with the tool, then you have to install a thicker piece. If it is in the middle, then there needs no changes. And then you basically use the spring compression tool, and you take out the current thrust plate or shim, whatever you want to call it. And what they want you to do is to use a mic and measure this thickness here, what is in there currently. Say like you have, it comes out, it's a 5.1 you got in here. Okay, now what you would do is, if you have plus, you got to go to 5.45. If you have minus, you go to 4.75. So on that valve, you have to write this down and then order these parts as they come. And that tool basically will just tell you is go one higher or go one lower from what you got in there currently. And then that's basically it. And that will work with this, say like if you're 25% on this unit here, and you think you can go from 5.1 to 5.8, that gives you more. That doesn't work that way, unfortunately. You have to do this in one step and then see what the system does and then retest it. So you go through all 16 valves, the 8 exhaust valves and the 8 intake valves. You change them out so they go back with the tool into the middle by changing these up or down. And then you run this here again and see what changes you actually got. Most of them then should be below 20, if not even below 10%. As older the engine is, you will have some leakage in there. You will not be able to close this off to zero unless you're doing this and you're rebuilding the engine. And that basically is the determination here, is once you get, say like you have already one cylinder on the cylinder heads, one valve at 40% loss or 30% loss, at that point I wouldn't even go any further. I would just take the whole head off and have the head redone or both heads redone. And then also inspect, of course, at that point the piston rings, sleeves and all of that good stuff. That will tell you that. And then of course your crankshaft bearings and you know what they look like, what the play is in there, how worn out they are on this, that and the other thing. So that gives you basically the idea. This is really the go, no-go thing, taking heads off, rebuilding the heads basically. Or can we do just a valve adjustment, valve clearances? I guess that would be called, most people would call it valve clearance adjustment. Or, you know, what sizes with those tools you can then determine it. And that will fix the internal vacuum leaks. And that will stop this here from bouncing, like in my case, from minus 18 to minus 22, minus 18, minus 16, minus 22, and it goes forwards and backwards. And every time this vacuum moves again, it's gonna change my timing advance. And if the ignition module is correct, like in mine, it goes from 14 to 17 to 16, pretty much close to this here, what the vacuum actually shows you. So you could say minus 18 is 14 degree. If you go to minus 22, you're gonna be at 16 or 18 degrees advance. So that gives you a pretty good idea, a practical hint. Yeah, but this is what's coming up. And the other thing is what I'm also going to be working on is the oil chain, because I'm not quite sure if that was changed. Checking out the oil pump itself and the strainer, the oil pump strainer. There's a filter or a strain with a system on the plugged in there, and we're probably going to change that too while we're at it, because I'm not quite sure if they did the oil chain or not when they did my timing chain. The timing chain was definitely changed, so we will see. I will keep you posted on this stuff, and you have a great evening.